What you are about to see should not exist. In one of the hottest places on Earth, coffee is growing. Not normal coffee. Giant coffee beans. Heavy. Bright. Fully developed. Right here, in the middle of the Sahara Desert. Coffee like Coffea arabica does not grow in places like this. It needs cool air. It needs rain. It needs shade. Here, there is none. Temperatures can reach 50 degrees Celsius. Rainfall is near zero. And still, these plants survived. Not only survived, they produced large coffee cherries. Inside them, giant beans. This shocked scientists, because coffee is sensitive. Even small climate changes can damage it. But here, in extreme heat, it adapted. This raises a serious question. Is the desert changing, or are we changing farming? Before we go back to day one, answer this. Would you drink coffee grown in the desert? Comment yes or no backhand index pointing down. Like the video, thumbs up. Subscribe bell. Because next, we go back to the beginning. Day 1. Before the coffee, there was nothing. Only sand. Endless sand. This part of the Sahara Desert has not grown crops for over 1,000 years. No rain. No rivers. No natural shade. Temperatures rise above 45 degrees Celsius. Sometimes even higher. The ground is not soil. It is dry sand. It cannot hold water. It cannot hold nutrients. And coffee like Coffea arabica cannot survive here. It needs stable conditions. Moisture. Protection from heat. But here, everything is extreme. Still, scientists chose this exact place. Not by accident, but by design. Because if coffee can grow here, it can grow anywhere. They marked the land, measured the distance, planned every step. No mistakes allowed. Because in this environment, one small error means failure. This was not just farming. This was an experiment, a test against nature. And at this moment, there were no plants, no green, no life, only possibility. Before we move forward, think carefully. Can life really start here? Comment possible or impossible backhand index pointing down. Like thumbs up. Subscribe bell. Because next, they begin changing the desert itself. Nothing grows in sand, so the land had to change. In the heart of the Sahara Desert, scientists began the transformation. Long trenches were marked. Straight lines. Measured carefully. Then digging started. The top layer was pure sand. Dry. Loose. Useless for farming. Deeper layers were harder. Hot. Compact. Still no nutrients. This confirmed one fact. Natural soil did not exist here. So they brought it in. Dark soil. Rich soil. Full of organic matter. This soil could hold water. It could feed roots. It could support life. The trenches were filled slowly. Layer by layer. Black lines appeared across the desert. A clear contrast. Black against orange. But soil alone was not enough. Water was still missing. And in this place, water decides everything. So they installed a system. Black drip irrigation pipes. Hidden under the soil. These pipes released water slowly. Drop by drop by drop. This method reduced waste. It protected the roots and kept moisture stable. This was critical for coffee like Coffea arabica, because too much water kills it. Too little water kills it. Balance is everything. Now, for the first time, this desert had nutrients, moisture, structure. It was no longer just sand. It was prepared land, ready for planting. But the real test was about to begin. Before we continue, do you think this setup is enough? Comment enough or not enough backhand index pointing down. Like thumbs up. Subscribe bell. Because next, they plant one of the most sensitive crops on Earth. Now comes the most fragile step. Planting. A coffee is not a strong crop. It is sensitive. Especially Coffea arabica. It reacts to heat. It reacts to water. It reacts to light. And here, in the Sahara Desert, everything is extreme. The plants arrive as small saplings. Young. Green. Delicate. Each one must survive. or the experiment fails. Planting begins slowly, one plant at a time. Each sapling is placed into the dark soil, not too deep, not too shallow, because roots need air. They need space. They need balance. Then support is added. Small wooden stakes to protect the plant from desert wind, because strong wind can break young stems. Then water begins. The drip system activates. Water moves slowly, drop by drop, into the roots. This is critical. Coffee roots cannot handle flooding. They need steady moisture. Now the plant stands still. No visible change. No movement. Because the real work is happening underground. Roots are adjusting, searching for water, trying to survive the heat. Hours pass, then days. Still no visible growth. This is the most dangerous phase. Because failure is silent. Plants can die without warning. And no one knows yet if these plants will survive. Before we continue, be honest. Do you think these plants made it? Comment survive or fail, backhand index pointing down. Like thumbs up. Subscribe bell. Because next, we see the first sign of life. At first, nothing happened. The plants stood still. No new leaves. No visible growth. Only heat. Only silence. In the Sahara Desert, this is where most plants fail. Quietly. Without warning. Coffee like Coffea arabica is extremely sensitive. It needs stable temperature. It needs moisture. It needs protection. But here, temperatures stay above 40 degrees Celsius. The air is dry. The wind is constant. Scientists watched closely. Every hour mattered. Every drop of water mattered. Days passed. Still nothing. Then, one morning, a small change appeared. A new leaf. Bright green. Fresh. Alive. This was the first sign. The plants had survived. The roots had adapted. They found balance between heat and water. This changed everything. Because survival means one thing. Growth is possible. More leaves began to appear. Slowly. Carefully. The plants were still fragile, but stronger than before. The desert was no longer empty. For the first time, there was green. And that green meant hope. Before we continue, did you expect this? Comment yes or no, backhand index pointing down. Like thumbs up. Subscribe bell. Because next, growth becomes faster. At first, growth was slow, careful, uncertain. Then, everything changed. The plants began to grow faster. Much faster. Leaves expanded. Wider. Thicker. Darker green. New branches appeared. Stronger stems. This was unexpected. Because extreme heat should slow growth, not increase it. But here, in the Sahara Desert, the conditions were different. Sunlight was constant. No clouds. No shade. This gave the plants more energy. More light for photosynthesis. And below the surface, water was controlled. The drip system delivered exact amounts. No waste. No overload. This created balance. A rare balance. Heat above. Moisture below. Perfect conditions. In an impossible place. Coffee like Coffea arabica started adapting. It adjusted its growth. Its leaves became stronger. Its structure became stable. Soon, the plants were no longer small. They spread across the soil. Green lines appeared, cutting through the orange desert. The transformation was visible. Clear. Real. The desert was turning green. And this was only the beginning. Because next, something even more important will appear. Flowers. Before we continue, did you expect faster growth in extreme heat? Comment faster or impossible, backhand index pointing down. Like thumbs up. Subscribe bell. Because next, the first flowers will bloom. Then one morning, something new appeared. Small white shapes, hidden between the leaves. Flowers. Coffee flowers. Bright. Delicate. Short-lived. This moment is critical. Because coffee flowers only bloom for a few days. Then they disappear. If pollination fails, there will be no fruit, no beans, no result. In natural environments, bees handle this process. They carry pollen, from one flower to another. But here, in the Sahara Desert, there are almost no bees, almost no insects. So scientists had to intervene. They pollinated the flowers by hand, carefully, using small brushes, transferring pollen from one flower to another. This required precision, because coffee like Coffea arabica is sensitive. Too much pressure, the flower is damaged. Too little contact, pollination fails. Every flower mattered, because each flower can become a coffee cherry. Days passed. More flowers opened. More pollination. More chances. The plants were no longer just surviving. They were reproducing. This was the turning point, because now fruit could form. Before we continue, did you know coffee flowers last only a few days? Comment yes or a no, backhand index pointing down. Like thumbs up. Subscribe bell, because next, the first coffee cherries will appear. A few days later, the flowers began to close. But this time, they did not fall. At the base of each flower, a small green shape appeared. Round, firm, very small. This was the first coffee cherry, the breakthrough, because this meant one thing: pollination worked. In the middle of the Sahara Desert, coffee fruit was forming. At first, the cherries were tiny, easy to miss, but they were alive, attached firmly to the plant, and growing. Day by day, they became larger, slow at first, then faster. Their color stayed green, but their size was already unusual. Scientists measured them carefully, repeatedly, because coffee like Coffea arabica usually produces small cherries. But here, these cherries were different. They were growing bigger, thicker, heavier. The desert was not stopping them. It was supporting them. Water below, sunlight above, perfect balance. Soon, the cherries were no longer small. They were clearly visible, across the plants, across the field. And this was only the beginning, because next, their growth would accelerate. And something even more shocking would happen. Before we continue, did you expect coffee fruit in the desert? Comment yes or a no, backhand index pointing down. Like thumbs up. Subscribe bell, because next, these cherries become giant. At first, the cherries were normal, small, green, nothing unusual. Then, they did not stop growing. Day after day, they became larger, faster than expected, faster than normal farms. In the Sahara Desert, sunlight never stops. No clouds, no shade, only constant energy. Below the surface, water stays controlled, exact amounts, at the right time. This creates balance, a rare balance. And coffee like Coffea arabica responded. The cherries expanded, their skin stretched, their structure became thicker, stronger. Scientists measured them, again and again. Each time, the numbers increased. This was not normal. Coffee cherries are usually small, but these were becoming large, very large. Soon, the color began to change, from green to yellow, then deep red, a sign of maturity, a sign of readiness. But something was different. Their size was far beyond normal. Inside, the beans were growing too, larger, denser, heavier. This shocked the scientists, because coffee does not behave like this. But here, in extreme heat, it adapted, and the desert was not limiting growth. It was accelerating it. Before we continue, do you think extreme environments can create stronger crops? Comment stronger or a no, way backhand index pointing down. Like thumbs up. Subscribe bell, because next, we reveal the final harvest. Months passed, and the moment arrived. Harvest time. In the middle of the Sahara Desert, coffee was ready. Not just ready, but massive. Large red cherries covered the plants. Heavy, dense, fully developed. This should not happen here, but it did. Scientists moved in carefully. Harvesting coffee requires precision. Each cherry must be picked at the right time. Too early, the flavor is weak. Too late, the quality drops. So they picked them one by one, slowly, carefully. The baskets filled up. with unusually large coffee cherries. Then came the most important moment. Testing. One cherry was selected, the largest, cut open. Inside, 2 beans. But not normal beans. These were bigger, thicker, more dense. This was the first proof. Then more tests followed. Weight, moisture, structure. Everything was measured. Everything was recorded. The results were unexpected. The beans were high quality, strong aroma, rich structure. Some results suggested even better density than normal coffee. Coffee like Coffea arabica had adapted to extreme heat, to controlled water, to desert conditions. This changed everything because it proved one thing: the desert is not empty. It is unused. With the right system, it can produce food, even sensitive crops, even coffee. This experiment opened a new possibility, a new future for farming. Before we end, answer this. Would you drink coffee grown in the desert? Comment yes or an O, backhand index pointing down. Like, thumbs up, subscribe bell, because the next experiment will be even more impossible.